All right, let's go into Ethernet IP trainings. Okay, the first slide is basically to give you a quick introduction. What is Ethernet IP? As you know, Ethernet IP is trademarked. So the way you write this is EtherNet/IP, and it stands for Ethernet Industrial Protocol. Ethernet IP is an industrial network protocol that adapts what you call the SIP, which is Common Industrial Protocol. It's managed by ODVA. It is actually one of the leading industrial protocols in the US right now, which we're estimating more than 30% market share right now. Ethernet IP make use of TCP for explicit messaging and then UDP for implicit messaging. And our FC6A CPU is actually support both. And Ethernet IP allows FC6A to exchange I/O and data information to devices that support Ethernet IP. So very similar to Modbus TCP, but there is a difference which I will go over in a little bit. So let's take a look at worldwide market share for Ethernet IP in a 4 years period from 2017 to 2020. The first row that you will see is basically Fieldbus. Fieldbus is considered non-Ethernet networks, such as Modbus RTU, DeviceNet, Profibus. In 2017, it has 48% market share. In 2020, this has dropped to 30%. And most of that drops is because of new industrial Ethernet protocol. So the second row, we have industrial Ethernet, such as Modbus TCP, Profinet, EtherCAT, Ethernet IP. 2017, it has a 46% market share. 2020 is 64% now. So now, if you're just looking at specifically for Ethernet IP, it is from 11% to 17%. Now this is worldwide, not US. At the earlier slides, I said the US is more than 30% right now. So dominantly, right now, US is using Ethernet IP. Okay, so just to give you a quick overview of what it is. Why would you want to use Ethernet IP versus Modbus TCP, for example? Ethernet IP allows you to do real-time controls, okay? Even if you configure it with other networks. Ethernet IP data can be prioritized when used with a QoS, which is a quality of services industrial Ethernet switch. Now the switch I have on this side right here is not ours, it's a competitor switch. But if you see they label as QoS supported, that means it supports quality of services. What that means is that, let's say you have an Ethernet switch here, and you have all kind of data coming through that switch. With the QoS service, the Ethernet switch will prioritize and say, okay, Ethernet IP data has the most priority, and it will send this information first before it sends other data. Okay, so that's what it is. Now, the other main difference between Ethernet IP and Modbus TCP is that Modbus TCP is not suitable for real-time control because it's not guaranteed. Because again, Modbus TCP data cannot be prioritized using QoS Ethernet switch. So that's one of the main differences. On this slide, I want to show you a quick overview of the different industrial protocols and then the MQTT protocol, which we are planning to support at the end of this year. I know this has been pushed back. MQTT is supposed to be launched at the same time with Ethernet IP, but we need more study, more research to make sure that we can support this 100%. So MQTT is pushed back. But as you can see on this slides right here, on the left-hand side, you have industrial protocol, which basically the POC is talking to all the field devices using this protocol, such as Ethernet IP, it can be Modbus TCP, other protocol to the controllers, and then the controller push that information to the database, which is a cloud database such as Amazon, Google, Apple, and so forth. Now that once that information is on the cloud network, you can basically, you have client devices. A client device could be a SCADA system, could be your PC, could be your tablet, or it could be your phone, and easily access to the cloud database. Now, the biggest benefits to MQTT is that your device, your client device, is not accessing the PLC directly, okay, by using an IP address. It actually accesses the database. So basically, the cloud database is the middleman that's converting, sending information. So there's more security because you're not accessing the PLC. Okay, so that's just to give you a quick overview of Ethernet IP and MQTT, how it's being used. Go back to Ethernet IP. An Ethernet IP device can be categorized as a scanner or adapter. Okay, there will be, just to give you quick warnings, there will be a lot of abbreviations, a lot of new terms that we're going to use. So I don't expect you guys to learn everything at this point, but just grab some information and then you will learn as you go from here. So a scanner is basically considered a master device on the network. An adapter is basically a slave device on the network. Okay, so most industrial protocols will stop at that. You either a master or a slave. But for Ethernet IP, there's more to it, okay? Furthermore, a scanner or adapter have roles. So their roles can be originator or a target. Originator has the ability to request and connect to the target. These features can only be found in a scanner device, okay? If you have a device that's categorized as a scanner, automatically it does have the originator function in it. Whereby the target is a slave device, is only waiting for the originator to connect to it. Okay. Now this target features actually can be found in an adapters or a scanner device. Okay. So hopefully does not get too confusing yet. So this slide's right here to explain it further. An Ethernet IP device can be either one is a scanner with originator and target functions, or B, a scanner with originator functions, and finally C, which is an adapter with target functions only. So most controllers, when they say they support Ethernet IP, it usually fall in this category A, okay? A controller, most of the time, is in category A. Category B controllers, you rarely will find that it only has originator functions. We actually never have not found a controllers that fall into category B yet. And then finally, category C is adapter. So adapter would be like a motor, could be a sensors, a VFD. So most of that would be categorized as C, which is an adapter with target functions only. So far so good, guys? Not confusing? Okay, so I want to go ahead. Okay, so I want to explain this further, okay? So in Ethernet IP, how it works is that it will have to establish a connection first, right? For it to establish a connection, let's say you have a scanner device. This scanner device has both originator and target function. If the scanner device needs to talk to, let's say, an adapter device, then the originator will be able to make a connection to the target, okay? Now let's say a second scenario where you also have a scanner on this side and then another scanner on this side, because this scanner has the target function and this scanner has the originator function. This scanner can make a connection to the scanner device on the left. So as you can see right here, if you have a device with this scanners with originator and target function, it can talk to adapters, and it also can talk to another scanner device. Okay, hope that makes sense. The second scenario right here you have is that let's assume your scanner device only has originator function. Okay, if this scanner device only has originator function, of course it can make a connection to an adapter device, but it cannot make a connection to another scanner device with originator function. Okay, so no connection here because this scanner device on the left does not have a target function. So the third scenario is very obvious. You know, you have scanners, you have adapters. Very easy connections. Okay. So once the connection is made between the target and the originator, data can be exchanged. Okay. So it depends on how you configure your data. It could be 10 words, it could be 20 words, doesn't matter. So your originators will send that information to your target, and your target can send that information to the originator. And this is going through periodically to a cycle. We call this an RPI, which just stands for Requested Package Interval. For example, if I set my RPI to 50 milliseconds and I want to send 10 words of data from originator, which is right here, to your target, and then the other way around, which is sending information from the target to originator. So at every 50 milliseconds, your data will be sending it to the originator and target. So this is the reason why we say that this is a real-time application, because data is updated at every RPI that you set. Okay, so that's a brief introduction of general how Ethernet IP works. So how it is support on our FC6A is that Ethernet IP is only supported on the plus CPU, and it's on port 2 of Ethernet port 2 of the plus CPU. Okay, the on one unfortunately does not have the power, does not have the memory to support Ethernet IP. So the FC6A Plus support Ethernet IP scanner with originator and target function. What this means is that our FC6A Plus is a scanner that has originator and target function. So it can talk to adapters, and it can also receive information from a different scanner devices. So what this means is that our FC6A can talk to a motor or VFD, and then also at the same time talking to, let's say, an Allen Bradley controllers. Okay, so this is what this drawing is. It's available as a firmware upgrade, so there's no additional cost, no additional hardware you have to deal with. Okay, it's all free. It will be available in AO version 3.19.0 or later, which is in WinLadder 8.150. We're planning to launch this at the end of this month, and I already sent you guys a link where you can download the software. So hopefully you guys are able to download and install it. Just two quick more slides on this. If our FC6A is configured as a scanner with originator function, up to 32 connections can be made. Basically, you can have up to 32 adapter devices. If our FC6A is configured as a target function to talk to other scanner devices, the maximum number of connection points is 8. Okay, so that would be 8. So basically 8 sets of data can be received from the scanners. Okay, so this is where I'm going to go into the actual demonstration or example how to configure how this works. This example number 1 is how to configure an FC6A Plus talking to an Oriental motor drivers. So the Plus will be configured as a scanner with originator function, and we'll make a connection to the Oriental motor, which is an adapter device. Okay, so this is how we're gonna do this. And after I show you all these presentations, I'm gonna actually show you how to do that in WinLadder software. Okay. Okay, so once you have the connections, data can be exchanged between the FC6A Plus and the Oriental motors. Okay. Now, in order to configure the FC6A Plus to communicate with the adapter, we need to find out some critical parameters in the adapter devices. The difference between Ethernet IP and Modbus TCP is that Modbus TCP, usually you don't have to know this key informations, but for Ethernet IP, you do need to find this information. So this information is such as vendor ID number, device type, number of occupied bytes, input data format, and output data format. This information are key for communication, so you need to find this information. And there are actually 2 ways of finding this information. The first way is, of course, for someone that likes to read the user manual, you go in there, you dig all this information. So I was able to download the Oriental Motors user manuals and find out this specific information like vendor ID, device type, and so forth. Now, for majority of us, we don't want to go through this process, right? So the second method is basically all of the adapter devices has what they call a EDS file. Okay, let me repeat that. All adapter devices have EDS file. Unfortunately, currently, because this is our first launch of WinLadder, we don't support EDS file import. Okay, even we have the EDS file, we won't be able to import this information into WinLadder. Okay, this will be the second phase at the end of this year, where we will try to support EDS file import. So for right now, even if you get the EDS file from Oriental Motor, how do you find out this information? So there is a extractor tool. Now earlier I said that Ethernet IP and SIP is managed by ODVA. So all the information you would have to put it in ODVA. So all the adapter devices information and even this tool can be found here. So I would recommend that everyone download this tool, okay, to basically extract those parameters. Okay, so the next step is basically I'm going to show you. Once you have that tool, you don't actually have to install it. It's a self-runs file. With this tool and then with that EDS file from Oriental Motors, I just open it and be able to find out what is the vendor ID numbers, what is the product code, what is major, minor revision, the product type, and some of these parameters. So these parameters are necessary for us to configure it in WinLadder. Okay. So the next step is I'm going to show you how to do this in WinLadder. So we'll go through the steps in the PowerPoint, and then we'll go back to WinLadder on how to configure it. So if you go to Ethernet, click on Ethernet port 2. Under Ethernet settings, click Configure. So you click Configure here. You check this box. You click Configure, and then check the Turn on Ethernet IP box if you want the FC6A to automatically enable Ethernet communication. So as you can see right here, we have a checkbox that will say, okay, every time the PLC turns on, you want to enable this Ethernet IP communication. Now, if you don't want to do that, you can actually controlling it in the ladder software, in the ladder program, by using this M8460 bit. Okay, so it's on and off Ethernet IP communication bit. So that's the first two steps. The next step is to configure the FC6A Plus as a originator device. You right mouse click on scan list, do an add target. Now under target setting, you enter the node name, which is any name that you want to say, the IP address of the Oriental motor, and then the electronic key. So this is where the information that I looked up in the EDS extractor tool. So the vendor ID is 187. You put 187 here. Device type 43, which is here. Product code 5094. A major, minor revision, and so forth. Okay. So based on that extractor tool information, you put that information here. Step number 5 is you right mouse click and select add SIP connection. Okay, under here you add a SIP connection. So the next step is in SIP connection setting, you fill in the adapter parameters. Okay, so you have input instant ID 100, size 28, output instant ID 101, size 20. So where do you find this information? Again, it's in that EDS file, and I will show you this where you look at it. Okay. So in the EDS extractor tool, you see that input. Okay. Now you know what? Let me explain that later. But for input, you see that T to O. The T stands for target. O stand for originator. So basically input is basically your originator inputs, basically reading information from the target. So in a way, the target is sending information to the originator. Okay, so that's instant ID is 100, you put that in. And number of words that's being used is 28, so you have to put that in. Now I just want to warn you that a lot of adapter devices, they define this in bytes instead of words. So in our one ladder, we use word. So basically you just have to divide it by 2 to get the word. So as you can see here, you have 56. It's basically half of that is 28, okay? And then for output, which is basically your originator sending information to the target, is 101, which is the instant ID. And the word is 20, you put that in here. Okay, so I just want to point out this information first, and then for the rest of the information, you fill it in based on this. So this will be the last steps of configuring Ethernet IP if our FC6A Plus is being configured as originator function. You have the SIP connection name. I'm not going to explain this. You can find this information in the user manual on page 440. So, but most of the time we would use exclusive owner. Okay. Timeout is basically it's obvious, self-explanatory. Is if you don't receive information within the RPI, which is your requested package interval times 16, if you don't get that information, you want some timeout. Configuration instant ID. Now, most adaptive device will support this and some don't. So it depends if this is available or not. So most of the time you would have to fill this in. But for the Oriental motor, it does not support it. So we just leave it at, you could either uncheck this or leave this as blank. All right, RPI, I explained this earlier, requested package interval. We could do it in 10 milliseconds up to 10,000 milliseconds. SIP connection point. multi-point or multicast. You know, I'm not going to explain this, but this is the difference between point-to-point and multicast. So you fill that in. Trigger of send is basically there's two ways to send data. It's cyclic, meaning that transmit data at the set RPI. So if I select cyclic and then I have RPI at 50, then basically at every 50 millisecond, data will be sent to the target or vice versa. Okay, and then you also have COS, which is COS, stand for change of state. The change of state is basically transmit data at the set RPI or when the value get changes. Okay, so you can use either one. The control registers is basically set the data register that will be used by the SIP connection. So if you wanna find out more information about how, so the control register occupies 5 registers, but actually only 1 bit is being used. The rest are being reserved. Okay. Top of device address is basically user-defined data registers in the FC6A. And that's it, you're done. That's the step to configure, to talk to, and adapt the device. Any questions so far before I go into a second example? Again, I'm going to go back to one ladder and show you the actual steps on how to do it after I'm done with this. No questions? All right. A second example would be to configure our FC6A, FC6A Plus. On the right hand side is a target device, and the control logics, AB control logics, is a originator device. So the control logic will initiate the connection to our FC6A, and then once we establish communication, data will be able to exchange between the two devices. Okay. So what you do is on the same process like earlier. Ethernet port 2, configure, check box, the enable Ethernet IP, click configure. Now instead of scan list, which we created earlier for the original function, we actually gonna go do the SIP connection point list. So right mouse click and then you add SIP connection point. So in this step is what we're trying to do is the FC6A will send whatever the values in D0 and D1 to the Allen-Bradley control logics. Now, as you can see, the instant ID is default to 100, but it can be set with other value. So whatever you set here in your AB control logics, it has to match. That's what you need to do. The SIP tag is optional if you want to use it or not. Type is basically for this would be inputs, right? So basically, the FC6A is a target. It's going to send information to the originator, which is the control logics PLC. So we're sending D0 and D1 to the control logics devices. Okay, so in top of device address, we're going to do D0, and then the size is 2. So it's basically occupied D0 and D1. This values in here will be sent to the control logics. Okay. Now, if you want to do this, if you would we basically repeat the steps to add other connection points. Okay. Now, the second, the next step is basically we're going to do the reverse. Basically, FC6A will receive data from control logics and store that data in D400 to D409. So in this case, we're going to use Instant ID 101. Now, the Instant ID cannot be the same, so it has to be different from every connection point, okay? The type we're going to use is going to be output. So basically, your originator, which is your Allen-Bradley, will be sending information, as you can see this small arrow here, to the FC6A, okay? So 10 data will be sent to D400. Actually, this is okay. So this is how you define it. Now this is the steps. So on one ladder side, you're done. Now to configure on the Allen Bradley size, you go to the RS Logix 5000. You select 1756. Select Add Module from context menu. I'm gonna go through this fairly quickly because most of us will not be familiar with the RS Logix software. So you select generic Ethernet module from module list. Configure properties of FC6A Plus. Okay. The FC6A Plus, actually, you don't have to fill this out because we do have, like I said earlier, we have most or all adapter devices have an EDS file. We also have an EDS file for FC6A Plus if you configure it as a target function. So actually this information, you don't have to, but for the purpose of this training, I'm going to show this here. So the IP address, which is right now is 192.168.1, I shouldn't use 6, but 6 right here. That's the IP address of the FC6A Plus. The assembly instant input and output, 100 and 101. As you can see, it was defined in here, 100 and 101. Okay, you put that in here. Assembly instant ID, we put in 1, right? We use a 1, and sometimes it's different from different manufacturers. So you put a 1 here. Okay, and then you just configure the RPI and click finish. So basically, that's all you have to do on the control logic sides. Okay. Now notice that we didn't configure the vendor ID, device type, and product type because some scanners do not require this information, but other scanners do require this information. So it depends on the different scanner settings. Now for identification, vendor ID, device type, and product code, and so forth, this information again can be found in the EDS file, which I will send it to you after this presentation. I'll send you this presentation and the EDS file. So the EDS file for FC6A Plus contains this information, but you can also find this information in our user manual, okay, in the FC6A. So that's it. That's all the steps that you have to configure, and that will be basically once you configure that, you should be able to communicate with other Ethernet IP devices. That's the end of my presentations. I will switch over to WinLadder to show you the actual steps and how to do it. But before I switch over to WinLadder, do you guys have any questions? No questions? Okay. All right, so on WinLadder size, make sure you have or select either the D16 or D32, okay? Because if you select other CPU, Ethernet IP is not available, okay? So the step that we did earlier is you select Ethernet port 2, okay? Once you bring up Ethernet port 2, there is a Ethernet IP settings. You check this box and you click configure. Okay, the next step, like I said, if you want Ethernet IP to automatically enable, then you check this box. Okay, so let's go ahead and check this box. The next step is because we want to be the master or the scanners with originator function talking to the Oriental motor, you highlight this scan list, right mouse click, and select target. Okay, that's one way to do it. Another way is to highlight this and click add at the bottom here. Okay, once you click add, you will see this menu right here. Okay, you want to go into target setting tab, which is right here. Okay, and then put in a node name So the node name we configured earlier, we call this Oriental motor. And the IP address of the Oriental motor is 192.168.1. Of course, this is a random IP address I just picked, okay? Now, electronic type, we're gonna do compatible. Again, vendor ID would be 187. Device type 43. Product code 5094. Now, like I said earlier, if we support EDS import, we don't have to configure all of this manually. So hopefully by the end of this year, we're pushing Japan to implement EDS file import, so we don't have to go this process, okay? So once you do all of this, division, major, minor, you put a 00, click OK. Actually, I should click OK. I'm sorry, go back. So you have it here. You configure it. So the next step is do a right mouse click and do add SIP connection. Okay, that's one way to add a SIP connection. Another way is you highlight this and click add. Okay, so, but for the ease of this, I'm going to do right mouse click and do add SIP connection. Okay, so this box right here is probably familiar to you, right? I explained this earlier. It's different SIP connection point that you can set. But before I explain that, I want to fill out the important parameters first, right? The important parameters would be the instant ID, which we have set it at 100, and for the inputs, and then for the output is 101. So in the instruction I gave you earlier, we use D100 and we use 28 words. Okay, so what this means is that starting from D100 to D127, okay, your target is basically your Oriental motor will send 28 words of data and store that in D100 to D127. Okay. For output, we define this as D200, and the size would be 20. Okay. So what this means is that output of the originator, which is your FC6A plus, okay, whatever the values in D200 to D219, you send that to the Oriental motor. Okay, so that's what it is. Okay, so those are the key information that you have to fill in for the adapter devices, which is the Oriental motor. The rest of the information, pretty much I leave it at default, which is SIP connection point. I leave it at exclusive owner, and you can study the definition for each of this on page 440 of the manual. So right now I leave it at exclusive owner. Timeout I leave at default here, but you have different settings that you can select. Trigger of send, I'm going to use cyclic. Okay, now control registers, you basically user define. I will put in D300 here. And basically that's it, we're done. Okay, so we're done here. Now SIP connection, you can do point-to-point or multicast, but I'll leave it at point-to-point. And basically that's it, you're done. Configuring the FC6A Plus as the originator talking to the Oriental motor adapters. Once you click that, you're done, okay? So you're finished with the first example on how our FC6A Plus talking to the Oriental motors. Now, the second example I show in the PowerPoint is having the FC6A Plus as the target device talking to the Allen Bradley control logics. Again, the steps is you go here, you check this box, which we did already, and click on configure. Now instead of configure everything here, you actually go in SIP connection point list, and you do a add SIP connection point setting. Right mouse click, again right mouse click, add. Okay, instant ID I'll leave at the default 100. I'm not going to use SIP tag. The input is basically the Allen Bradley will receive information from our FC6A Plus. So I put in D0 here, the size is 2. So the values in D0 and D1 will be sent to the Allen Bradley units, okay? And basically you're done with one settings. And to repeat the steps, I'm gonna go here, right mouse click, add SIP connection point. Now instead of selecting input, which is basically sending information to the FC6A Plus, I'm going to do output. Output basically receive data from the originator, meaning that our FC6A Plus will receive information from the Allen Bradley. Now for the instant ID, the default is 100 again. You don't want, like I said, you want to be different. The number here has to be different from the earlier one that we configured, which is 100. So I'm going to configure this as 101. The type, I will select output. Address is D400. And here you define as a size of 10. Okay? And that's it, you're done. You have configured Ethernet IP settings to communicate. There's two communication that you can see here. Here you're talking to the Oriental motor as a originator device, and here you are sending and receiving information to the Allen Bradley control logics. Okay. Now I don't have the Allen Bradley software to show you the other steps, but on the win ladder side, you're done. That's all you have to do. Okay, so I'm gonna click OK and get out of this box. That's it, you're done.